Hi there, this is Abhishek, and in this video I will talk about how you can decompose a time series and do the forecasting. So before I move ahead with this video, I received a couple of questions from my previous video where I explained about the simple moving average and exponential moving averages. And the question I got is specifically related to the exponential moving averages, where it was mentioned that SMA is, however, relatively simple to understand because it's a simple moving average. You just take a average of that period and continue with that, and it gives us the result. So it's quite easy to understand. But in case of exponential moving averages, we are introducing the ratio parameter, which basically assigns the weight to the values and to the analysis. So basically, yesterday I basically showed you these three examples, and today, for the sake of explanation of how exponential moving averages works, I added this particular piece, which is starting from taking only one observation into consideration where for doing the average. That means the first observation as it is. So the basic idea behind working with the exponential moving average is that whatever weight that you are assigning over here, you are assigning this weight to the most recent observation, and to the previous observation you are assigning the weight of 1 minus this particular value. That means 1 minus 0.25, so 0.75 to the previous observation, and then we get the output. So if I run this for you, and no need to plot, probably I just print it. So this is the output that we are getting. So first observation is 1580, and second observation is 1575, third observation is 1618. And if we look at the base data, here we have 1580 is the first observation, so that's fine. Second observation is 1560, but exponential moving average is giving you 1575. Third observation is 1750, but exponential moving average is giving you 1618. So how these values are coming? So question was that it was difficult to understand. So what I did is I created an Excel sheet where I took this process. So that's the EMA of one period with 0.25 as a weight. So 0.25 I have just mentioned as a static value. So if I drag it down, so 0.25 is just the static value for this column B2, and what I'm doing is after that I'm putting a calculation. So because it is one period, 1580 will remain 1580 as it is, as you can see. But for the second observation, that's what our algorithm is doing in the back end. So what it is doing is it is taking the most recent observation, as I mentioned, and multiplying it or assigning the weight. So A4 multiplied with 0.25, right? And then adding the previous observation with 1 minus weight. That's what the process is to get the exponential moving average. Assign the weight to most recent observation and its reverse to the previous observation. So if you compare 1575 with the R, so that's the 1575 you are getting. Then the third one is 1618.75, 1618.75, 1565.813, 1565.812. So almost like 99.99% it is identical. Only obviously because the calculation engine of Excel and R is different. Probably R is more accurate, what I would say. That's why you are getting that point. Instead of 0.813, you are getting 0.812 within the R. Now if you would ask what we will do in case of 3 period average, then the basic idea is that start with the 3 period average. So if I take this 3 and show you the average over here, which is 1630, that will become my first observation. And for next observation, I will apply the same formula. So if you go back into the R And for 3 period average, if you see, which we calculated yesterday, the first 2 observation is blank because we are taking the 3 period average, and the first observation for from third period is 1630 as it was here, and then based on the calculation you are getting the subsequent values. So I hope now the process is clear to you, what is really happening in the backend of exponential moving averages, and what do you really mean by 0.25. Generally, as a practice, what happens is that people assign aggressive weights to the most recent observation but not this lagging weights. So generally what you would see is 0.6 or 7.5 or even 8. But I would really recommend that keep it between 0.6 to 0.8. Beyond that, assigning the weight, it's really a matter of your subject matter expertise on the data, and then you are free to do an experiment whether more weights are giving you the better value. Alright, so with this process is clear, let's go ahead and see how we can decompose the series. So to do the decomposition of series, one arrangement we may need to do is we need to convert our yearly time series into a quarterly one so that we have a cross section of data. So for example, if we are having this sales TS like this, and if I show you sales underscore TS, so this is a vector kind of information where for the time series, and if we try to decompose it, it will not it will throw us an error because decomposition is based on the 3 component which is trend, seasonal, and any irregular one. So this is something required, that time series needs to be some cross-sectional data, what I have observed. So for example, if we are going here with the sales underscore TS and saying that we need a quarterly data, then we go ahead and put Control Enter, and then if we see the sales underscore TS, this is basically saying that okay, in 2000, quarter 1, quarter 2, quarter 3, quarter 4, it will basically very clearly show you what is a trend, what is basically cycle is, or seasonal cycle is, and if there is any irregular component. And if we plot this, if I go down and plot.ts and say sales score TS, Control Enter, that will basically show you the clear, seasonal and cyclical trend which is required, or a requirement for a decomposition function. So let's try to decompose that. Sales underscore TS underscore decomp, and use decompose sales underscore TS. Control Enter. Now if we plot sales underscore TS underscore decomp, if you see, this is not plot.ts but simple plot function, and it is plotting us the 4 section. The first section is the observed. This is what they are observing. Then they are saying the trend. Okay, this is how the trend is looking like. Then the seasonal. Then the random errors or random fluctuations. Now, if you think that your requirement is that you want to remove some component, say for example the random component, then from the time series, then what you can do is sales underscore TS underscore without underscore random, and say sales underscore TS minus sales underscore TS underscore decomp $random. Control Enter, and with that what you will get is the time series without the random fluctuation or error. So if we see, it is starting with quarter 3 and 479308 is the observation, and here you have 47442. So just wanted to throw an idea about how you can really do this particular piece and remove whether it is a random error, or if it is seasonal, or if it is trend, anything based on these main 3 components. Alright, so with that, let's move ahead and try to do some forecasting. So in this video I will show you some quick forecasting or simple forecasting using the exponential smoothing forecasting, where basically 3 observations comes into the picture. The first one is that time series is constant and there is no much variance or anything, and your trend and seasonal component are constant. So how you can do the forecasting in that case. Then second scenario comes when you have the trend in your data, and finally when you have the seasonal, and then both trend and seasonal. So we'll see in a couple of commands how we can really go ahead and do that. So to do that, first of all, we need to take the data. So what I have is the rainfall data in mm, annual rainfall data in mm for Indian region, and let me rain_India, and I need to read the file, so read.csv, and I'm going to choose the file. Once I press Ctrl Enter, it will open up a dialog box for me, and I need to go into the downloads. So if I go to downloads and rain, so here I have the data set. So now I have the data, and rain_India_TS. What I would say is TS, and then the object name, and it is starting from 1901 and completing in 2013. So Control Enter. Alright, yeah, that's the mistake. Control Enter. And now if you plot the data, plot.ts, which is the first requirement for time series analysis, and I'm getting the error in plots label. There are more than 10 time series as multiple. So let's evaluate what we are getting. India_TS, Control Enter, and we have a time series. So for some reason it is starting from October, December, or it's mentioning that. So let's try to give it a frequency is equals to 1. Control Enter, and now let's see how it is plotting the data 1901, and whether it will going to plot this time. So still it's giving some error. So I just paused the video and checked that I was picking up the wrong file, and the data where I have the time series data in the for annual time series is a different file. So let's do this picking up the file process again. Control Enter, and if I go back again in my downloads and say annual, alright, now let's try to convert it, and now let's try to plot it. Okay, it's working fine. So because the last file was having multiple columns, and because of that it was not able to identify which particular column is containing the time series data. So this particular time series is basically telling us that it is pretty much having the constant variance over a period of time. Along with that, if we see in mm, it is somewhere down there 1200 mm, you would see a constant mean which is there. So since the trend is not present and seasonal component is also not present, which looks like from this time series, let's go ahead and apply the simple exponential smoothing forecasting process using the halt winters. So I believe halt winters is something which not available, so we need to probably import a library which is forecast, but I think that is mainly for forecasting after doing the testing with halt winters. So let me quickly check halt winters, control enter. So it is present in the stats package, so it should be by default available. So let's go ahead and see the data. Rain underscore India underscore TS, and we will say HW for halt winters and say halt winters, and then we provide the time series, and time series is rain underscore India underscore TS. We will only we will make the beta and gamma as false, because that is a requirement when you have constant time period, and you will only get the output for alpha, which is basically to see how good or bad your time series is doing when you are trying to predict it with the halt winters against the actual values. So control enter. Now let's see their values. Score HW. So if you can see, we are getting a quick output. So we have a smoothing parameters. Alpha is coming as 0.15 and the coefficient value is 115.5. So what does this indicate? So since alpha value is near to the 0, it is saying about exponential forecast that halt winters has done the prediction by placing the weight both near to the observed and the current and the next value, and that's how it has done the prediction. So a less weight to the recent value and more weight to the previous value. Now after that, what we can do is we can make rain underscore India TS underscore. We can see the fitted value. Control enter. So if we go here, so this is basically your predicted value and this is your actual value, and if you see, it has done an amazing job in kind of predicting it, because it's almost same thing that it is predicting which was there. So if you remember from our previous videos, x hat is nothing but the predicted value. So that's quite good. I mean, I was not expecting this, but that's quite good that the fitted value is coming. Now the thing is, let's say we want to do the forecast for maybe next 3 years until 2015. Then what we can do is we can use the library which is forecast, and it has the method for halt winters for doing the forecasting. So to do that, we'll use forecast, and within the forecast dot halt winters, and we will provide this rain underscore India underscore TS HW. The one we use the halt winters method over here, and H is equals to, let's say, 3. Control enter. So here is the forecast for the next 3 years, and it is saying that it is a constant value of 115.517 with the confidence level at which is saying that minimum is 981, maximum is this, and at 95-degree confidence, what is the rainfall, what the rainfall will be. So that's basically, by specifying the number of period, it should give you the output. So this is helpful in short-term forecast, like 1 year or maximum 2 years. As you can see, it is giving us pretty much the similar value, and the main reason why it is giving us a similar value is because the variance is pretty constant, and because of that, the only good way is by looking at the low and high value at 95-degree confidence and 80-degree confidence. What you can do is you can even plot the forecast. So to do that, again we will use plot.forecast method. So important thing is that these 3 columns that you need to use with a package name, then only these particular functions are coming. Otherwise, if you will directly use, which you usually do with any other package, it will give you an error, or it will not show you forecast.altwinters or plot.forecast. So this thing I figured it out because it was giving me an error, and I just searched it and see why the problem is coming, and it's mainly, I think, because of how it is integrated into the current R environment. So with that, let's try to plot the value, but first of all get the value into the object. So rain underscore India underscore T underscore HW underscore FCST, control enter, and then same. So this is our entire time series, and this particular value is basically saying that this is the forecast, point forecast. This is the at 80 degree, the shaded area, which you can see little bluish and gray color, and then this proper gray color, their boundaries are saying at 95-degree confidence what is the forecast. So this is completely based on the variance that it has seen in the observation when it is going up, down, and based on that it has given you the variance that these can be the boundaries which you can safely consider for the upcoming years. So with that, I want to stop here so that it is not too much for you. I would really like that you look at your own data set where you are seeing that there is a constant variance, there you are not seeing any trend or any seasonal thing, just a constant variance, and try to follow the similar prediction methodology which we have used it over here with these different packages. And in the next video, then I can cover the rest of the 2 other methodologies. So thank you for watching this video, and I will meet you in the new video with a new topic.